Problem 2.37. In this problem, we have a U-tube manometer which is connected to a tank containing air shown in the figure below. At the close end of the manometer, there is air at a pressure of 16 psi. We need to determine the reading of the pressure gauge for the differential reading of 4 feet on the manometer. Express your answer in psi gauge. Assume a standard atmospheric pressure and neglect the weight of the air column in the manometer. Okay, so the first thing that we're going to do is we're going to label the different locations that we're going to analyze. So we're going to start with this one. If you notice, we take this value inside of the air pressure. We assume that the pressure differential is very small, so it doesn't matter whether you evaluated it over here at the top or at the bottom. We assume that the pressure is about the same because the fluid is air. The next point will be this point over here. And then our third point will be here. Notice that we do not choose a point inside of air. There are a couple of reasons. One, there is not a height that is provided. Two, because it's air, we could make the same assumption that we had before, that the value of the pressure inside of the air or the differential pressure is going to be very small. So if we choose this point or this point in top of the water, it will be basically the same amount of pressure. Okay, so these are the three values of pressure that we are going to use. Okay, and we are going to evaluate the value of pressure at point 3. So we do P3, and we start at P1, plus we go down, so it's positive, and we go gamma of the fluid that is given over here, times the elevation. We're going to call this elevation H1, and this elevation H2. And then we go from point 2 to point 3. Once again, we go down, so it's positive. And this is gamma of water times H2. So for now, we're just going to write the constants, and then we will replace at the end. Okay? So notice that we have P1. P1 is given as 16 psi. That means that is an absolute reading. They're asking us to do the evaluation in terms of gauge. So the first thing that we need to do is convert P1 from absolute into gauge. So we have P1 is given as 16 psi. We're going to remove the value of atmospheric pressure, which is 14.7 psi. And this is going to give us 1.3 psi. So now this is the value of the gauge pressure at P1. Okay, then we do P3. Therefore, it's going to be 1.3 psi plus gamma of the fluid. So the gamma of the fluid is given as 90 pounds per feet cubed. The elevation is going to be 4 feet. Then we add gamma of water, which we have as 62.4 pounds per feet cubed. And we multiply by that elevation, which is 2 feet. Okay. So the first thing that we're going to do is we're going to continue doing the calculation. So we do P3, 1.3, this is PSI. And then the multiplication of these two values gives us 360 pounds per foot square. And this multiplication gives us 124.8 pounds per foot square. The addition of these two, notice that it gives us 484 484.8 pounds per foot square. Because the units of these two quantities are not the same, we cannot add it. They're asking us to get the value in psi, so we're going to convert this quantity into psi. To do that, remember that we do 1 foot is equal to 12 inches, but because we have a square, we have to square both top and bottom. And at the end, this number gives us 3.36 psi. Now, since they are the same unit, we could add it. Therefore, the value of P3, which is the pressure at the gauge, is equal to 4.67 psi.